Right, in this session we have to know the next topic, that is evaluation of integrals by using Laplace transform. How can you evaluate the integral value by using the Laplace transform? We know the definition of the Laplace transform. What is that? We know that what is the definition of Laplace transform? L of f of t, L of f of t is equal to integral 0 to infinity e power minus st f of t dt. Okay, integral 0 to infinity e power minus st f of t dt. This can be written as, first I can write this integral. What is that? Integral 0 to infinity e power minus st f of t dt is equal to what happen? L of f of t, L of f of t. Right, so by using this definition, we can evaluate the integrals of the form integral 0 to infinity e power minus st f of t dt by using the Laplace transform. What is that? If the integrals are in the form of integral 0 to infinity e power minus st into f of t dt form, then by using the Laplace transform we can evaluate this integral value. Right, now let us see the problems on evaluation of integrals. See the first problem, evaluation under the evaluation of integrals. So the problems, the first problem is evaluate. First problem is what that? Evaluate integral 0 to infinity t e power minus 3t, t e power minus 3t sin t dt, right? So we have to evaluate this integral 0 to infinity t e power minus 3t sin t dt. How to evaluate this? See here, if you observe this one, right, in the form of what this integral is in the form of integral 0 to infinity e power minus st f of t dt form. Right now write it. What is that? First, how can you solve, how can you evaluate this integral value? Right, see what is the given data here. Given that integral 0 to infinity see I am writing first e power minus 3t, e power minus 3t. Right now next I can write a t into sin t. Right, I will take this one as one term into dt. This is the given integral. Now I have to evaluate this one. What is the form of this integral? This is of the form what is the form of this integral? This is of the form integral, this is of the form what is that? Integral 0 to infinity e power minus st f of t dt form, f of t dt. Okay, if you compare these two, where s is equal to what is that? Where s is equal to what is that? 3, f of t is equal to what is that? F of t is equal to t sin t, right? Now what do you want? We need this integral value. Right now this integral is in the form of what is that? Integral 0 to infinity e power minus st f of st f of t dt form. So if the integral is in the form of 0 to infinity e power minus st f of t dt form, by using the definition of Laplace transform, it can be written as what is that? L of f of t, L of f of t. Right, so see here, hence by the definition of Laplace transform, hence by the definition of Laplace transform, we have what is that? Integral 0 to infinity e power minus st f of t dt is equal to what is that? L of f of t. Right, but what is f of t here? Here f of t is what is that? F of t is t sin t. So take what is that? F of t is equal to, take f of t take f of t is equal to t sin t, then what happen? Therefore integral 0 to infinity e power minus st f of t means t sin t into dt is equal to what is that? L of t into sin t. Right, now this integral value is equal to that Laplace transform of t into sin t. Now we have to find L of t into sin t value. How can you find? This is in the form of L of t power n into f of t. What is that? This is in the form of what is the form? This is in the form of L of t power n into f of t form. L of t power n into f of t. So what is the formula? L of t power n into f of t minus 1 whole power n into d power n by ds power n of f bar of s. F bar of s, or it can be written as what is that? L of f of t. L of f of t. Right. So by using this formula, what is that? Multiplication by t power n property. L of t power n into f of t can be written as minus 1 whole power n into d power n by ds power n. D power n by ds power n of L of f of t. L of f of t is nothing but f bar of s. Now I am using that formula. What happened by using that formula here? See here, by using that formula, it can be written as minus 1 whole power n into d power n by ds power n of L of f of t means here f of t is nothing but here sin t. Right, in this case here f of t means sin t. So this is equal to minus 1 whole power n. N value is what that here? Minus 1 whole power n means t power n. Here n value is 1. Minus 1 whole power 1 d by ds of what is that here? L of sin t. L of sin t. Right. So this is equal to what happened? What is the next step here? This is equal to minus 1 whole power 1 is nothing but what is that? Minus 1, right, d by ds of what is L of sin t value? L of sin a t value is a by, here a means 1 by s square plus a square means 1 square means 1. So this is equal to minus, differentiate this one. This is in the form of derivative of 1 by x. What is the derivative of 1 by x? What is the derivative of 1 by x with respect to what is that? X. What is the derivative of 1 by x with respect to x? What is that formula? Minus 1 by x square. Here x is nothing but what is that? S square plus 1. So see here, what is the derivative of this one with respect to s? Minus 1 by s square plus 1 whole square. But it is not only s, we have s square plus 1. So again we can differentiate s square plus 1 with respect to s. Right. So this is equal to, here minus of minus 1 is 1 by s square plus 1 whole square. Now what is the derivative of s square plus 1 with respect to s is 2s. So this is equal to what happened? 2s by s square plus 1 whole square. S square plus 1 whole square. Right. So this is the value of what that? This is the value of integral. This is the value of integral 0 to infinity e power minus st t sin t into dt. So this is the value of integral 0 to infinity e power minus st t sin t dt value. But what do you want? We need the integral 0 to infinity e power, what is that, minus 3t t sin t dt value we need. Means we can put s is equal to, what is that, s is equal to 3. Then we can get, what is that, integral 0 to infinity e power, in the place of s you can write 3, e power minus 3t t sin t into dt is equal to, what is that, 2 into 3 by 3 square plus 1 whole square. So this is equal to, what is that, 6 by, here 9 plus 1, 9 plus 1 is 10, 10 whole square means 100, right? What is that, 3 square means 9, 9 plus 1 is 10, 10 square means, what is that, 100. So this is equal to, what happens if you cancel this one, 2 3s 2 50s, right? So you can get the solution of the given integral is 3 by 50. So what is the value of the given integral? The value of the given integral is 3 by 50, right? So see here how to evaluate the given integral. If the given integral is in the form of 0 to infinity, we can use the definition of Laplace transform. So by using the definition of Laplace transform, we can evaluate the integrals which is in the form of 0 to infinity, right? Now moving to the second problem. Now the second problem is, see that, evaluate integral 0 to infinity, integral 0 to infinity, integral 0 to infinity e power minus root t, e power minus root 2 into t, right, into sin ht, sin ht into sin t, sin t by t into dt, right? Now we have to evaluate this integral. Right now how can you evaluate? First we have to observe what is the form of the given integral. Here see, the given integral is in the form of integral 0 to infinity, what is that, e power minus st into something like that, right? So we can evaluate this integral value by using the definition of Laplace transform. How we can solve? See that, what is that, what is the given integral here? Solution, I can rewrite the given integral as, how can you rewrite the given integral? See here, I am writing integral 0 to infinity, I can write this one as e power minus root 2 into t into, what is that, I can write sin ht into sin t by t into dt, right? Now this is of the form, what is the form of the given integral here? This is of the form, integral 0 to infinity e power minus st f of t dt form, f of t dt, where s is equal to, what is s here? S is equal to minus root 2 and f of t, what is f of t here? F of t is equal to sin ht, sin ht into sin t by t, sin ht into sin t by t, right? Now we have to evaluate this, right? Okay, integral value by using the definition of Laplace transform. The given integral is in the form of integral 0 to infinity e power minus st f of t dt, where s is equal to minus root 2 and f of t is equal to, what is that, sin ht into sin t by t. Okay, now see how to do the solution of this problem. Okay, right? Now you can observe this one, how to do the problem. Hence now I can use the definition of Laplace transform. Hence by the definition of Laplace transform, hence by the definition of Laplace transform, we have what that integral 0 to infinity e power minus st f of t dt is equal to L of f of t. Right? What is f of t here? Take f of t is equal to what that sin ht into sin t by t. Right? So therefore what happen, integral 0 to infinity e power minus st what is that sin ht, f of t means sin ht into sin t by t into dt is equal to integral of that L of f of t. F of t means here sin ht into sin t, sin ht into sin t by t. Now we have to find this Laplace transform of sin ht into sin t by t by using the division by t property, right? So first of all we have to find L of sin ht into sin t value, and then we can apply the division by t property, right? So take this one as equation number 1. So one by one you can do it. See here, first what that I can find the value of L of sin ht by t, then I can apply the division by t property. Now first I can find L of sin ht into sin t value, sin ht into sin t. So how can you find this one? We can write this one as L of if you have the hyperbolic function, we can write hyperbolic function in terms of exponential. How can write sin ht in terms of exponential? E power t minus e power minus t by 2 we can write, right, into what is there, sin t. Now this is equal to 1 by 2 is a constant, keep it outside, and what is that, apply the Laplace transform to the remaining terms. What happen, L of e power t into sin t, this is one term, L of e power t into sin t minus what is their second term, L of e power minus t into sin t. So this is equal to what happened here, 1 by 2 into what is the form, this is L of e power at into f of t form, means this is in the form of L of e power at into f of t, means what is that, by using first shifting property first we have to write L of sin t value, then you can change s to s minus 1. Here also in the second term also what that, it is in the form of e power minus at into f of t, first we can write L of sin t value, then we can change s to s plus 1. So by using the first shifting property, so first I can write L of sin t value. What is L of sin t? L of sin t value is what is that, 1 by s square plus 1. Here I can change s to s minus 1 minus, here also what is that, first I can write L of sin t value. What is L of sin t value? 1 by s square plus 1. Here you can change s to what is that, s to s plus 1, s to s plus 1. Since what is that, since by using first shifting property or first shifting theorem, right? Now what is the next step here? See here, this is equal to what happened, 1 by 2 into in the place of s you can change s minus 1. Right, put that in the place of this is equal to 1 by 2 into, in the place of s here you can write s minus 1. What happened? S minus 1 whole square plus 1 minus, here in the place of s you can write s plus 1. What happened? 1 by s plus 1 whole square plus 1. So this is the value of, what is that, L of sine ht into, what is that, sine t value. Now what do you want? Now we want L of sine ht into sine t by t value we need. Sine t by t value we need. So how can you find this value? This is in the form of L of f of t by t. L of f of t by t means by using division by t property. Division by t property you can write integral s to infinity f bar of s. F bar of s means L of f of t. L of f of t means here L of sine ht into sine t, right, ds. So what is that? By using division by t property, division by t property, by using division by t property, right? So this is equal to, so what is the value of L of sine ht into sine t value? 1 by 2 into 1 by s minus 1 whole square plus 1 minus 1 by s plus 1 whole square plus 1, right? Okay, so here what is 1 by 2? 1 by 2 is a constant, keep it outside of the integral. Then what happened here? 1 by 2 1 by 2 integral s to infinity, what is there, 1 by s minus 1 whole square plus 1 minus 1 by s plus 1 whole square plus 1, right, into what is that, ds. So this is equal to 1 by 2 into, now this integral is in the form of integral 1 by x square plus 1 into dx form. What is the integration of 1 by x into dx here? What is the formula? Integral 1 by x square plus 1 into dx is equal to, what is that, tan inverse of x, tan inverse x. So by using this formula, the first integral can be written as, what is that, how can write, tan inverse of s minus 1, and the second integral is also in the form of 1 by x square plus 1 form. So this can also be written as tan inverse of s plus 1, right? Now what are the limits? S to infinity. Now substitute the upper limit. What happened? 1 by 2 into, so tan inverse, in the place of s you can write the upper limit. What happened? Tan inverse of infinity minus tan inverse infinity. If you substitute the upper limit, minus of substitute the lower limit in the place of s. What happened? Tan inverse of s minus 1 minus tan inverse of s plus 1, right? So now what happened here? tan inverse infinity value is what that pi by 2 na. Tan inverse infinity value is pi by 2, right? So pi by 2 minus what is that pi by 2 we can get it. So this is equal to 1 by 2 into what is that pi by 2 minus pi by 2. So what is that minus tan inverse of s minus 1 minus minus is a plus tan inverse of s plus 1. Here pi by 2 is cancelled, so this is equal to what is that 1 by 2 into what is that tan inverse of s plus 1 minus tan inverse of s minus 1, right? Now I can simplify this one. How can I simplify? 1 by 2 into, this is in the form of what is that tan inverse a minus tan inverse b, tan inverse a minus tan inverse b form. So this can be written as what is that tan inverse of a minus b, tan inverse of a minus b by 1 plus ab, 1 plus ab. So here a means s plus 1, b means s minus 1. So by using this formula it can be written as tan inverse of what is that a means s plus 1 minus b means s minus 1. So minus of s minus 1 means minus s plus 1. Okay, so minus s plus 1 by 1 plus a means s plus 1 into b means what is that s minus 1. So this is equal to 1 by 2 into tan inverse of what happened here, plus s minus s is cancelled, we can get 2 in the numerator, right? Now what happened, 1 plus, this is in the form of a plus b into a minus b na? This can be written as a square minus b square. A square minus b square means s square minus 1, right? Here plus 1 minus 1 is cancel. Then what is the next step here? Next step is 1 by 2 into what is that tan inverse of 2 by s square. 1 by 2 into tan inverse of 2 by, so 1 by 2 into tan inverse of 2 by s square. So this is the value of what is that L of sin ht into sin t by t value. This is the value of what is that L of sin ht into sin t by t value, right now. Substitute this value in equation 1. Substitute this value in equation 1. We get what is the equation 1? Equation 1 is what is that integral 0 to infinity e power minus st, what is that sin ht into sin t, sin ht into sin t by t into dt is equal to what is that L of what is that L of sin ht by sin ht into sin t by t. What is the value of L of sin ht into sin t by t value? 1 by 2 into tan inverse of 2 by s square, right? But what is s value? S value is root 2 na? So we can put s is equal to what is that? S is equal to root 2. Then what happened? therefore integral 0 to infinity e power minus root 2 into t into what is that sin ht into sin t by t into dt is equal to 1 by 2 into tan inverse of 2 by root 2 whole square. So this is equal to 1 by 2 into tan inverse of 2 by what is root 2 whole square means the square root and square is cancelled, then you can get 2. So this is equal to 1 by 2 into tan inverse of 1. What is tan inverse of 1 value? So tan inverse of 1 value is pi by 4 na? So this is equal to what happen 1 by 2 into pi by 4. So tan inverse of 1 value is 45 degrees. 45 means pi by 4. This is equal to what happen pi by 8. So this is the value of the given integral, right? So just I have used the definition of Laplace transform. I have evaluated the given integral value, right? Okay, so this is the second problem of the evaluation of integrals, right? Now we have some of the problems. I can give them, you can practice. So please note down that evaluate third problem is what is that? Evaluate integral 0 to infinity e power minus t into cos at minus cos bt by t into dt, right? Next fourth problem is evaluate integral 0 to infinity e power minus at minus e power minus bt by t into dt, right? And the fifth problem is evaluate integral 0 to infinity e power minus t sin t by t into dt. So you can practice these three problems, then you can